Hi, it's Mrs. Green, and today's lesson is on the distributive property. So to distribute, I have a little graphic here for you. It means to give out. So usually the word helps us figure out what the property is about. And in the little picture here, the teacher is giving out an 8. Who wants an 8? I do. So she's distributing the 8 to the items that are inside the parentheses. Another thing I like to think about when talking about distribution or distribute. So if somebody's giving something out, maybe for free, like if you go to Costco and you're walking around and they give out the free food for samples, they're distributing. So they're giving out free samples. So next time you go to Costco, you could say to your mom or dad, I'm going to go get some free stuff that they're distributing. You can impress them with your vocabulary. So the distributive property, the key information is typed right here. You can multiply a number, a single number, and a sum, so you will have the single number in front usually, and then the sum will be in parentheses. Two other numbers. You can distribute the 4, you can multiply the number by multiplying the number in front with each of the parts of the sum, and then adding those together. So my 4 gets multiplied by my 5, I get 20. It gets multiplied by the 3, I get 12. And then you can add those two together, and you get 32. Now I know that you could have gone to this original problem and added the 5 and the 3 using the order of operations, and get 4 times 8, and also get 32. But we're trying to illustrate the distributive property, which is going to come in handy, especially in algebra. So let's look at let's look at some examples. Oh, no, actually, before we look at more examples, or right in our example section, I want to give you one more definition. So I want you to write in your key information the definition of an equivalent expression. And an equivalent expression happens when you rewrite an expression. So if I have a distributive property situation, I'm going to rewrite this expression. This is an expression. So I have an expression here with multiplication and addition. I'm going to rewrite it using the distributive property. Actually, you know what? I'm going to write all the steps. So I'm going to do 5 times 2, and then my plus sign remains. I'm going to add 5 times 4. Then I'm going to simplify. So I've rewritten the expression as an equivalent expression. It looks different, but it's still the same value as the original expression. And then I'm going to simplify. So every time I write a new expression, that's considered an equivalent expression until I get down to the simplified value. So that's what an equivalent expression is. I didn't give you a typed up definition. I think you can see by the picture what it is, and you can write it in your own words. Try to describe for yourself what an equivalent expression is. So we're going to use that when we use the distributive property. So your examples for the distributive property are, so I've got an example A here, and it's got a variable in it. So we're going to start working with variables. So I have an x, and it makes a little more sense using the distributive property when there's a variable, because I can't add the 10 and the x inside those parentheses. I can't do anything there. So the next step I would do in my order of operations is to do the multiplication with the negative 5. So I'm going to multiply the negative 5 times the x and get negative 5 times x. Multiplication is implied because there's no symbol in between the negative 5 and the x. Then I'm going to write my plus. Then the negative 5 times 10 is going to give me negative 50. And that would be almost complete. The last thing I want to do is, you never leave a situation where you have a plus and a minus next to each other. You would just change it to subtraction. Even though we went to the trouble of changing addition to subtraction, sorry, other way around, subtraction to addition, we're going to change it back to subtraction in the end to write it completely perfectly. And that would be the distributed equivalent expression for A. Let's do B. Okay, example B looks quite a little bit more difficult. It's got three three terms being added together within those brackets. Now I know you could solve that in the brackets and then multiply it by the 3, but we're going to use the distributive property to illustrate how it works. So I'm going to multiply the 3 by each term inside the brackets. So that's going to be 3 times 1. And then I'm going to carry my sign. And then I'm going to multiply 3 by 20. I'll write it out here if I have room. And then my last term is going to be plus 3 times negative 5. I ran out of room. And then simplifying that, I'm going to scoot over and rewrite my equal sign so that I have room. 3 times 1 is 3. Minus 3 times 20 is 60. Plus 3 times negative 5 is negative 15. So now I'm going to simplify this. I'm going to change subtraction to addition and change my sign of my 60 to the opposite. So 3 plus minus 60 plus minus 15. I'm going to combine my two integers that have the same sign. That's going to give me a minus 75. And then I have subtraction I have to use. And I get 72, but it's a minus 72 because my integer has a minus sign in front of it. Okay, for practice, you're going to use the distributive property to write an equivalent expression and then evaluate. So I know that you could solve this by combining the numbers that are inside the parentheses and then multiplying, but that's not how we want to practice the distributive property. So you want to rewrite it as an equivalent expression using the distributive property. So you need to distribute, then you can solve, which is the same as evaluate. Simplify. Okay?